Thank you for joining this webinar. I'll be presenting from Displayr as it's designed for interactive presentations. However, everything I show you except the simulator can be done in Q as well. Conjoint's the most advanced technique in widespread use in market research. We're going to do a deep dive into conjoint over 8 weeks with 5 separate workshops. Today, I will focus on providing an overview and the planning of the data collection side of things. We'll be doing it as a workshop with opportunities for you to ask questions, give comments and interact. We'll be doing a live project together. We'll create the conjoint part of the questionnaire today. Over the next 2 weeks, my team will hopefully collect the data. Then we'll go through the process of turning the data into insights and the story. We'll be using the GoToWebinar app to interact. Now you'll probably have a little floating toolbar on the screen that looks like this. Just click the red button, really orange button with the white arrow in it to expand it out, please. Now there's a little raise hand button, but don't click that because I won't notice it. We're going to mainly use questions and polls as our way of doing the interaction. So as a way of just checking that you've got everything working, can you just type hi into the questions field for me? And if you can't see it, you might need to expand it out. And Ashish is the winner. Great speed there, Ashish. And good morning to you, assuming you're in Australia, or good afternoon if you're in America. And morning for New Zealand, etc. Great, all right. I think everybody seems to be getting that working. And Ashish is in Sydney. Cool. Now, no need to go any more highs, but feel free to. And do stop me at any stage by typing something to the question, typing comments to the question field. I may not spot them initially because it's a bit hard to multitask, but I'll do my best. Now, we'll do a little poll. Got half of you voted so much so far. Morning, Helen. 80% voting. It's fun, isn't it? It's like an election. All right, cool. We're past 90%. So let me share those results. And so these are the results that we got. As you can see, there's a mix between those 3 categories. And don't worry, the webinar that we're doing today is designed with that mix in mind. We will email you a recording of this webinar, as well as some additional articles that we've written on some kind of more involved topics that we're not going to go into today because they're not applicable to our webinar, or our case study, I should say. Conjoint is an area where there's lots of jargon and lots of jargon police that love to get into debates about definitions. What I'm talking about today is often called choice-based conjoint, or in academic worlds, discrete choice experiments, but it's got 101 other names. The key defining aspect of this technique is the way the data is collected. People are asked to make choices between hypothetical products with questions like this one. The descriptions of the alternatives change from question to question. Typically, people are shown as few as 1 such question and as many as 20. Using very, very complicated math, which we'll do in a couple of weeks, automatically, don't worry, we can predict why people make the choices they make. And the cool thing is that once we've done that math, it can be used to make predictions about what people will do when faced with products we haven't shown them. By analysing questions like the ones shown on the left, we can answer research questions like these. I'll give you a moment to read them. If you're a true research ninja, you can even start to make predictions about sales and market share. But I put a caveat here. It's really hard to do these research objectives well. Most people do stuff it up most of the time, I'm sorry to say. So be very careful when providing conjoint services to make sure that answering the easy questions will provide significant value for the stakeholders, because if the only thing they're interested in are the pink stuff, you might be in a bit of trouble. But let's dig into how conjoint allows us to understand what people value. As a very simple example, look at question 3 on the bottom left. Imagine that we've got the data for one respondent and they chose the Godiva option on the left. I want you to look at the question and see what you can work out. Why would somebody have chosen Godiva in that case? What do we learn from that choice? And type your answer into the questions field, please. Dipesh says they value single origin, and that's right. If you compare option 1 with option 3, they're identical, except option 1's promoting single origin, option 3 is sugar-free. So we can say they prefer single origin Venezuelan Criollo beans over sugar-free. Nice work, Georgia, as well. Now there's clearly some additional information here. There's something that they prefer about this Godiva bundle over this Hershey's bundle, but we can't work out what. To work it out, we need to make some assumptions. We need to make 4. The first assumption that we need to make is that products can be described in terms of attributes and levels. And these are the attributes and levels that we used in the study that we've just looked at here. And the art of doing a good conjoint study is making sure that you collect the attributes and levels that allow you to answer the objectives of the study. And we'll return to that in a case study that we'll work through a bit later. The second key assumption is that a person has some quantifiable level of preference for the different attribute levels. This level of preference is known as utility. Here, for example, the data shows preference for Dove versus Hershey's. Dove is preferred, Godiva is preferred to Dove, and Lindt is liked the least. Note that Hershey's utility is set to exactly 0. This is actually neither a result nor an assumption. We only calculate relative utilities when we do conjoint. That is, technically, we don't actually estimate the utility of Dove. We estimate the utility of Dove relative to Hershey's. And so we set Hershey's to 0. We could equivalently estimate the utility of everything relative to the average of everything else. It's a different approach. Gets you the same basic answers in the end. We'll return to this in the next webinar. Now, conjoint estimates the utility for each attribute level for each respondent, and that allows us to make predictions about the respondents' choices in the questionnaire. Assumption 3 is that we can sum up the utilities of each of the attribute levels to deduce the overall utility of a product. And the last assumption is that people are most likely to choose the product with the highest utility. Now, you did a good job, a few of you did, in working out preferences from question 3 before. But the clever math that we're going to use is something which has got the name of hierarchical Bayesian estimation of a mixed logic model with a multivariate normal mixing distribution. Now, that's a slightly vague and imprecise explanation, but it's also still too long. And so usually we refer to all of that as just hierarchical Bayes, or HB for short. Now, this is the output we'll get when we estimate hierarchical Bayes in either Q or Displayr, and we'll go into its interpretation in a couple of weeks. At the moment, I'm just giving you the overview. The more glamorous output is the simulator. It allows us to answer what-if questions. This simulator is showing us that the chocolate described here for Godiva gets 10.1% share of preference relative to the other alternatives. What happens if they replace the standard sugar with a sugar-free sugar? Dun, 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 dun. We lose share. We go from 10.1 down to 9.6. So this is one of the great outputs. The other really great output are demand curves and similar types of charts. This one here And then I've got a quick question coming in from Georgia. Can you have a simulator in Q, or is this just in Display? Simulators are in Displayr in our software, but a lot of people create them in Excel as well. And so you can export your data from Q into Excel, but the Display ones are much cooler. So here's one of the other kind of key outputs where you get a demand curve. In this case, I'm doing it for sugar-free chocolate. And on the far left, we see that given a choice between sugar-free chocolate and not having sugar-free chocolate, 32% would choose sugar-free chocolate. That is, most people prefer to not have sugar-free chocolate. But this is where the conjoint gets really cool, because we can see what happens at different price points. And so we can see that, for example, at 60 cents, if we charged a premium of 60 cents for sugar-free chocolate, we'd still get 26%. So we haven't lost many customers when we've raised the price. We can raise up to $1, and we've still got 20% of people who want to buy it. At $1.50, we've got 16% of people who want to buy it. So this curve is telling us something really useful. Sugar-free is not a mass market proposition. Given a choice, most people want sugar. Obviously not been watching the same documentaries as me. But it's a feature that the people that do want it are prepared to pay a pretty sizable premium for. And it tells us that we would probably want to build an expensive sugar-free chocolate bar. And this research was done before these bars started to become popular. That's the overview. How do we actually do the study? We start by trying to work out what the objectives are. In my case study, and the one that you're going to help me design and analyze over the next 8 weeks, these are my objectives. I'll give you a little chance to read them. Now, if this was a normal research study and you're the researcher and I'm your client, you should be arguing with me about these, but we're going to skip that step. This is the list of the typical types of objectives that people address in conjoint studies. The ones in blue are the ones that relate to the actual objectives that we're going to do in the case study. All right, so we now need to move forward and choose attributes and levels. A lot of studies will just use 2 attributes. They'll have brand and price. These are particularly useful in pricing studies, and they're also useful in studies where we're trying to look at deletion of products. This is an alternative to using a technique like TERF. Or we might have 3 attributes. So in the soft drinks market, it's quite common that you might have brand, you might have the format, was a small can, large can, etc., and price. And that allows you to create lots of SKUs from your model, something you can't so easily do in a TERF study. However, if we're doing, say, a segmentation study or product design study, we may have many, many more attributes. Here is one with 14 attributes relating to the home food market that we did in a study a few years ago. People can have many, many more attributes than these even sometimes. How many attributes should we have? There's a very simple answer to that question. 1. The fewer the attributes, the better. There's a very straightforward trade-off here. The more attributes you have, the lower the quality of all of your data. And there are lots of reasons for that. So there's always a bit of a negotiation. Is a particular attribute worth the loss of information that comes from adding it? Now, here are the attributes that I'm proposing to use for our case study. And I need your help to work out how I can improve them. I shared the objectives before. These are the attributes that I've come up with. Now's the time to fire in your comments and your questions, because I'm going to collect this data, and I'd hate to discover the attributes are bad after I've collected the data, because that makes one sad. Just type them into the questions field. Well, I'll give you a few thought starters to think about as we work through this. It's important that attributes and levels describe all interesting current and future scenarios. So if you're doing a study on the car market, having an attribute like miles per gallon of gas or kilometres per litre, petrol, as we'd say in Australia, isn't very sensible because it doesn't allow you to forecast appeal of an electric car who's got energy costed per mile or kilometre. Can anybody see anything missing here in my design? Another kind of check we can use is attribute levels must be mutually exclusive within and across attributes. So one that comes up quite a lot in airline studies and banking studies as well is where there's kind of non-obvious overlaps. And if you look at the bad example in the top right-hand corner, if you've got one attribute, which is the minutes spent in the queue at security at an airport, and another one, which is the time taken from getting to the gate from arriving at the airport, these two things potentially contradictory, and they're certainly measuring the same things. Yeah. Now, Jonathan asks, why is less attributes better? Well, less attributes are better for the following reasons. The first one, and there's many more reasons, I'm sure, but the first one, the key one, is the more attributes, the more complex the questions get. The more complex the questions are, the more confused people will get, and the lazier people will get, and so the more they're going to guess. And that's just how we work as human beings. The more complicated our questions, the worse our answers will be. The second thing is, the more attributes we have in a study, the more we actually rely on assumptions when doing the analysis. There are lots of aspects to this. So let's say I've got a single attribute. What brand do you like the most? Brand, I can ask a question like, what brand do you like the most? And I can know the answer for every person. But if I've, say, got 20 attributes and brand is one of them, I actually cannot from that even work out confidently which brand each person would like the most. I can estimate it, but I can't know it. I've got to make a whole lot of mathematical assumptions to perform that estimate. All right, we're getting some comments in here now. Vincent says, salary needs ranges rather than 5, 10, 15 to 20%. All right, let us move forward, Vincent, because I have got that. I know exactly why you're saying that. Descriptions need to be unambiguous. And this is a classic distinction between conjoint and lots of other bits of research. So ranges of price are a terrible thing to do. Similarly, ranges of salary, you don't want to do them because the person who's completing the questionnaire probably assumes they'll get the high amount of the range. The person who is analysing the results will make a different assumption. And if the person who's completing the questionnaire is viewing the option as meaning something different to the person analysing the data, you have got poor quality research. So you definitely don't want to use ranges. Other kinds of things, you want to keep descriptions simple, and this is usually contradictory to the desire to make things unambiguous, and there are contradictions like that we have to resolve. We want to delete any nice to know attributes. Anyway, let's go back and look at these other comments. George has said, do you need an option of zero distance so that you can model someone who walks from home all the time? So distance is irrelevant. Good. Yeah, we could have a zero option, a zero distance here. That's certainly something to do. And what that really flags is that to analyze this data correctly is going to be a little problematic because there's an interaction between work location and distance from workplace from home. If I'm fully remote, this is irrelevant to me. But if I'm not fully remote, it becomes relevant. And that's going to add a considerable complication to how we'd want to analyze this data. And it actually makes experimental design really hard. So we want to try and remove the interactions if we can in some way, see if we can come up with some clever way of removing it. And I'm looking for you guys to help me with that. Dipesh says, attribute 2, should we switch the description to fixed bands, like in the next 21 to 30 years? Now, look, again, the next 21 to 30 years, and we talked about the ranges before, but this is a good example, right? Think of your average cynical corporation. If the cynical corporation says, we're going to do it the next 21 to 30 years, there's a good chance they mean 30 years. But when you're analyzing the data, does it actually mean 21 or does it mean 30? You've just got no way of knowing. So you do want the precision, and you can interpolate other things using some maths that we'll come back to in a few weeks. Helen asks, why are there gaps? Yeah, and this is a great question. So this is different to a normal questionnaire where we're asking somebody what they did. So when you ask somebody what they did or how old are you is a good example. If you said, how old are you? I'm 20, I'm 40, I'm 60, and you're 42, you can't answer the question. But we're not asking people to provide data about what they did or who they are. We're just asking them about what they like, and we can fill in the gaps. And filling in the gaps is called interpolation, and we will come back to that. Jenna says, should there be negative adjustments to the salary? Yeah, maybe there should be. We could equivalently do, 10% lower, 5% lower, same as current, and get rid of some of these higher ones. That would definitely be a valid thing to do. Because conjoint focuses on differences, it won't actually necessarily get us a very different result if we changed it that way. But I'll tell you why I didn't do that. I didn't do that for two reasons. One is typically people get pay rises by changing job. It's actually not that common, and it does happen, but it's not that common that people elect to change jobs for lower salaries. That's one reason. The other reason is, as of today, inflation is going around the world. So it would be a brave person who took a new job at a lower salary. Crystal says we can say distance traveled every day for work, one way. Yes, that would certainly be a way of solving that. We could do that, but there's a bigger problem hidden in there. Now, Marion says we shouldn't show distance from home in choices where fully remote is in the choice. And that is an excellent way that we could solve this problem. And what you do, what Marion's essentially proposing, there's two ways you can do this. You can do something called a prohibition, where you have a rule where you go, okay, we're simply not going to show one attribute when the other's there, or we're going to prevent certain combinations from appearing. I tend not to like them. They've got lots of technical problems. I think they're generally a bad idea. The thing I would prefer to do is create a super attribute where you combine these two attributes together. So it could be work in the office every day, less than office, work in office 1 mile from home every day, work in office 2 to 5 miles from home every day, etc. That'll be one way to do it, but there's some other things we can do. And Barney has pointed out something important, and Barney's completely right on this. When I explained the objectives before, this distance from workplace isn't related to any of my objectives. I only included it in the study because I think it's relevant. That's a nice to know. You don't want to have nice to knows in your conjoint studies. So we're going to get rid of it. And that will actually solve quite a few of our other problems. So I've got it as a spreadsheet here. Goodbye, distance from workplace. And Kevin has pointed out that tradies don't work from an office. And so this becomes a very ambiguous or confusing question. How do we fix that? Well, one way we could do it is we could, well, that's actually good. The only way we can easily solve that problem is to filter our sample to only ask the question to people that work in an office every day. Damien asks, sorry, Eric, okay, Eric. Eric says software descriptions are pretty ambiguous. And Eric's right, these are ambiguous descriptions, Eric. How can we improve them? Lots of comments coming. Damien says, are old software and industry standard software mutually exclusive? Yeah, that's a good question. They may not be mutually exclusive. So I'll push it back to you. I agree that you've found something that's bad, but how do we fix it? And Georgia said, could you say work on site? Yeah, that's a good idea. We could change office to on site, but the problem you get to of trading, so let's say my job is that I'm a bricklayer. I can't work from home ever. So I'd really have to either exclude the bricklayers from the study entirely or have a conjoint where I fix their work location to always be working, on site every day. Andrew says, could we rephrase the question to work in the office to travel to work? Interesting idea. Travel to work every day. Well, it's still not going to help us with the tradies though, is it? I don't think that's going to work. It's a hard one. I'm still thinking I need to just only ask the question, have this attribute for people who I know come to an office. All right. Vanessa says, are you missing something related to how valid global warming is as a differentiator when recruiting staff? No, I don't think I am. My goal is to work out if global warming and net zero emissions are relevant. And that's what we'll learn from the study. So one possible result we get back from the study is we find that the utilities of each of these options here are almost identical and much smaller than the salary. And my guess is that's what we will find. And we'll find hopefully a segment of people who really value it. But that's what we're trying to learn from the study rather than, I think, an assumption going in. Natasha says, should we name the software? Look, that would definitely make them less ambiguous. But the problem we get to is different industries use different bits of software. And we would have, in North America, which is where I'm going to field this, my recollection is there are 24,000 separate job role descriptions or something like that when they code the census up. That's going to be one very complicated questionnaire if I have to put a software description in for each of them. Scott says, some would say that Q is old software, but at the same time, it's best in class software. Look, you've all nailed the problem with this attribute. It's not a great attribute, but I don't know how to fix it. So give me a solution. Ian says, maybe say version 1.2.3 instead of old new. Maybe. I'm nervous about doing that because, Q's on version 6.12.17 or something. Marion says, brickies don't use software much. And you're probably right. I mean, the tradies do. They do invoicing software and stuff like that. But, yep, that also is another reason to filter it out and maybe get rid of the tradies. Yeah, Aiden wants me to get rid of the tradies, as does Vincent. All right. So I've clearly got some problems I need to think through. I'm going to have to resolve them after this, or we'll spend the whole day discussing this. Now, let's move on to our next few bits. So thank you for your input. Now we move on to designing the choice questions or tasks. And there's three phases to this: the experimental design, choosing the question type, and deciding whether we're going to have none of these and current options. But what is an experimental design? An experimental design takes the table of attributes and levels that we've created, and it turns that into a questionnaire, as we can see here. And this is actually what a design looks like. It's a massive table. And some of you are going, that's not a massive table. It's only got 11 rows, but it's only showing the first 11 of 300 rows. I'll shortly show you how to create such tables, but let's focus on working out how to read them. So you'll remember in our chocolate study, there were 4 brands: Dove, Godiva, Hershey, and Lindt. And so I can just substitute these numbers for the labels. Now, typically in a conjoint study, you have multiple versions of the questionnaire. That is, maybe you give 10% of the sample one set of questions, another 10% of the sample a different set of questions, and that's what you do if you had 10 versions. So in the experimental design, the first column shows version. The second column shows task, which is really the same thing as question in this context. Whoops, clicked the wrong button there. So I showed you the mapping down here. What I'm now going to do is show you how we actually construct a questionnaire from the design once we've filled it in with words. And the first row is showing us the first option in the first question, but the first question goes over 3 rows. So we can see that the second option appears in the second row, so almonds, almonds, and the third option in the third row. And I'm showing you this information because some of you who'll need to program a questionnaire, it is about creating all lookups and stuff in your software to pull the data out of some big table into these questions, or if you're using Qualtrics, there's a little button in Displayr and you can just directly pull the design into Qualtrics, and with Q as well, I should say. Or another thing you can do is use your data collection software to design the experiment and therefore avoid a lot of this particular pain, but maybe not get as good a design, I'm not sure, and then just do the analysis in your analysis software after. So how do we actually create the designs if we want to? Here are the instructions for doing it in Q and Displayr. We will actually do it though. All right, now, when you don't know how to do something in our software, you type it into the box at the top and it will search through, in this case, the menus and show you where it is. And so you can see I've got two places for experimental design. I could do it for MaxDiff or choice modeling. And choice modeling is the technical name for the analysis, which includes the analysis of conjoint data. Now, I've inserted it and I've got an error. No data has been provided, and a bright red button, which is where I need to add in the data on my attributes and levels. So this is what we've come up with before. It's going to be a bit like playing a computer game. We need to get rid of all errors and warnings. So the next error we've got is it's telling me there are insufficient questions or versions in your design to fit a model. So I need to increase the number of questions times the number of versions to more than 14. Now at the moment by default, and it's just a default, it hasn't done any analysis to do this, we've got one version and we've got 10 questions per respondent. Now what I can tell you is generally if you've got 10 versions, the world is good. So you usually want to have at least 10 versions. More is better, but it's very marginal. Having said that, I like to have one version for every respondent if I can, but let's just put 10 versions in. All right, and we got rid of our errors, which is great. And we've also got some warnings we need to solve. So the first warning is telling us that the maximum standard error is 0.074. Now, standard error is a measure of uncertainty in our estimates of the utilities that we're going to get. And it recommends, and this is a standard textbook recommendation, that we should have our standard errors below 0.05. And so we should consider either having a larger sample size, and if you look here, this assumes a sample size of 300, or we can increase the number of alternatives or reduce the number of levels in the attributes. Now, I don't want to reduce the number of levels. I quite like these levels. I could have a larger sample size, but I'm going to want to explore this idea of increasing the number of questions. To do that, not questions, sorry, number of attributes. And to do that, I need to preview the experimental design to get a little feeling for what it looks like. So I'm going to click Preview Choice Questionnaire. And it's going to put a little preview of the questionnaire here. And no, you cannot send this to respondents to complete. We don't do data collection. I'm going to drag it to the bottom of the page and then we'll just scroll down and have a look at it together. All right, so when you look at this, have a go at trying to answer question 1. Is it too hard? And Scott tells me that we're up to Q 5.13.1.0. Thank you for telling me, Scott. I don't use Q anymore, so Scott does, so he's more up to date than me. I use Displayr now, in case that's not clear. I don't think, nobody seems to think this question's too hard to answer. Let us go though and modify it now and see what happens when we've got 4 alternatives, because that's one of the ways we can collect more data. The more alternatives is the more data we collect for complicated mathematical reasons, which I'm not going to go into. All right, and we got rid of one of our errors or warnings that we had before, which was good. Not one we've even looked at, but it's nice that it's gone. Is this questionnaire too hard to answer? You're all professional researchers, so have a look at it. Is the question, is anybody who thinks, no, I couldn't expect a respondent to answer that? Vincent says, apologies, may have missed it. Was this a spreadsheet that could be pulled into Q and Displayr? No, we're actually creating the design in Q and Displayr, and we can export it from Q and Displayr to other programs, or we could export it and then re-import it as well if we wanted to. Catherine says, the questionnaire is fine if I'm doing it on a web browser, but it's a problem if I'm going to do it on a mobile phone. And that's a really good point. Since mobiles became popular, I've tended actually not to do structure the way I present them like this to respondents. I tend not to do tables like this. What I instead do is include the attribute name in the level description. So I get rid of this thing to the left, and I would say, rather than say same as current, I just say same as current salary. No commitment, I go no commitment to net zero emissions. It makes them marginally more verbose, but it means that when they get wrapped around or whatever in a mobile device, questionnaire works a lot better. Eric, who's a legend, says he reckons it's okay to answer, so I'm going with you, Eric. Okay, what is next? Now, there are some more complicated issues, and we're going to send some articles dealing with these that come up. Sometimes, and this came up, somebody made this comment before, you want to prohibit certain levels from appearing together. So in one of the little case studies we've got, you want to prevent Ferrari from appearing with low price. I hate using prohibitions, and the reason I hate using them is you tend to have a lot of problems at analysis stage when you use them. And the particular problem you have is you tend to inadvertently mean a lot of differences cease to be statistically significant just due to the use of prohibitions. So I'm not a big fan. I think the art is to come up with attributes that don't require prohibitions in general, or to do something called utility balancing, which is the next point, which is, and there's various names for this, they can be called Pareto efficient designs, things like that. The idea is that you create your questionnaire such that you know that each alternative is fairly similar in terms of the appeal, because that way, theoretically, you get more information from them. Of course, it's been found that it's more tiring for respondents to answer these, so maybe they make up answers a little bit more. Another complicated issue is interactions. We touched on that. I'm not going to go into that now unless somebody's got a desperately specific question. The thing that we do need to talk, though, about is partial profile designs. We talked before about how the more attributes, the worse your model is and the worse your conjoint is, all else being equal. But the sad reality is that you always find yourself in situations where you need to do many more attributes than you want. I've worked on studies with as many as 30 attributes. Scott, who's on this, is, my guess is Scott's got to 1,000, but he'll come back and tell me that I got that wrong. And it can be very difficult with some clients to explain that they've got a quality issue and they just know they need to get the data. And so how do we address that? Probably the best way, and there's no perfect solution to this problem, but my preferred way, and Sawtooth have lots of little tools designed specifically for this problem, so check them out as well, but is to do what's called a partial profile design. Now, when we created this experimental design, it's defaulted to something called balanced overlap, which is a pretty good general purpose design. But if we use something called partial profiles, it will allow us to specify the number of attributes that are shown per respondent. So in the earlier study where I had mentioned the 14 attributes for fast food, we only showed 8 per respondent. I think it was 6, can't remember. And so the partial profile tries to create the best experimental design given that constraint. But the thing to be really clear about here is there's no free lunch, right? If you've got 12 attributes and you only show half of them to each respondent, you need to double the sample size relative to if you have 6 attributes. You're definitely losing a lot of information when you do these partial profile designs, and they require larger samples. Ashish says, can the attribute list be reduced using MaxDiff before conjoint? You could do it, but it'd be an extraordinarily complicated questionnaire because you'd have to measure the MaxDiff. So you could do it across multiple stages. If you've truly got a large number of attributes, like 30 or 40, or maybe even 20, you should probably consider some of the special Sawtooth technologies designed for those large number of attributes. Having said that, as a consultant, my strong belief is the smarter thing to do is to work really hard with the client and reduce the number of attributes, because the techniques designed for dealing with large numbers of attributes, I find, and it's something I've looked into a fair bit, tend to be extremely unreliable. But other people will tell me I've got it wrong, as Scott just has. Thank you, Scott. Scott, you can add some more comments and I'll read them out. A number of the people on the call, like Scott and Eric, have done lots and lots of choice models in their lives. All right, having come up with our experimental design, we need to choose our question types. The classic way of choosing our question type is to do a choice question, such as this. A more complicated style of question is a best-worst question. And this is best worst conjoint, which is different to max diff, but it looks very similar. So you ask them which of the alternative they like the most and which they like the least. Now, when you do this, you get more data, which means you can get away with a smaller sample size. So that's good. But it's an intrinsically less valid form of question. The reason that choice-based conjoint became popular is because we're asking questions that are similar to how information is presented and collected in the real world, right? When you go into a bank, I'm showing my age, when you choose a banking product, they do present you a grid of options and you do choose the one you want to buy. And the questionnaires you do in conjoint closely mirror that. And it's that mirroring which makes you feel reasonably confident there's a chance the results are going to be valid. But banks don't say, and also tell us which product you like the least so we don't accidentally give it to you. And so when we get data like least likely, it's just a less realistic data collection format. It's a bit more hypothetical, and that is going to have some unknown effect. Whether it's big or small, really hard to say. You can get even more information from ranking questions, but they've even worse got that problem, and they're tiring to fill in. And we can ask people constant sum questions. Again, these get even more data, so you can have a smaller sample size, but I will actually say you shouldn't do this. These violate an assumption of conjoint. So let's say, for example, that we've got this sign here and our respondent goes, I'm going to give an 8 and I'm going to give a 2. Now, the math of conjoint implicitly assumes that when the person did this, what they were telling us is that there's 80% probability they'll choose Dove and a 20% probability they'll choose Hershey. But you can't be confident that's what the respondent meant. For example, it could be that this is a study being done in America and the person completing it eats most of the chocolate and they like Belgian chocolate, and so they chose this option, but grandpa refuses to eat foreign foods, only eats made in USA, so they got 2 bars for grandpa. Now, if that's what's happened, the model assuming that these are probabilities is just going to be wrong and the conclusions are going to be wrong. Another way of collecting more detailed information is to just ask how many that you would buy. And this is even more problematic than the previous approach. Like, it seems so clever, and I will confess to having done a lot of these in my life, but at analysis stage, it's really, really hard to work out what differences are noise versus are we expanding the category. It's just, the data becomes pretty close to unanalyzable without making heroic assumptions. And Scott tells me he wasn't disagreeing with what I said, other than that he had never had more than 1,000 attributes. Fair enough. Ahmed, hey Ahmed, he says, is there a rule of thumb about the ideal number of choice that would be tested? And do you mean separate questions? So as I said before, I'm going to assume you do, Ahmed, unless you add some additional information. As I said before, you can do a range from 1 through 20 questions. I say you can do a range of 1 through 20. There was a very famous researcher in this field who just died last week called Jordan Louvier, who maintained that you could ask people 20 or 200 questions like this. Now, I personally, if I'm getting my choice, would only want to ask people 1 or 2 questions, because I think the more of these questions you ask somebody, the more hypothetical they become, the lazier they get, and the more they just treat it like a computer game rather than revealing their preference. But it's rarely commercially practical to only ask people 1 or 2 questions because you need a huge sample size. So when I've done my commercial studies, I've often asked as few as 6 questions, sometimes even 4. I think most people tend to ask in the range of 12 to 16, however. Another approach to collecting the data is to give people mock questions. You can show people, for example, a store layout on a screen. You can get a bit further and have virtual reality type things. Back when I was younger, we'd regularly is a bit of an exaggeration, would occasionally fit out a room as a shop with stuff on the shelves and things like that. And all of these things increase the likely validity of the first choice that somebody makes because the question's more realistic. The problem though is you tend to not be able to ask as many because it's expensive and time consuming to set these up. And so your costs go up a lot. You need a much bigger sample size. There's a real trade-off that you have to make there. But how should we make that trade-off? Let's do another little poll. Georgia says, what's the difference between best worst conjoint versus max diff? There's a simple way to think about this. Best worst conjoint and max diff are almost identical, except that max diff conjoint doesn't produce any predictions about what people will do in the future. It doesn't allow you to say, if you combine these three attributes together, your product will be purchased by 25% of people. So that's kind of the biggest, huge difference. The other one is that attributes in a max diff study are tested for whether they're there or not. You know, do we offer this feature, yes or no? Whereas in conjoint studies, we can have lots of levels, you know, $5, $10, $15, $20. And the ways you can hack that into max diff, but they're pretty unsatisfying. And Marion and Helen are saying choice, but let's complete the questionnaire, and 51% have voted. So you're all seeing the questionnaire. Hopefully it's coming through. And Marion, you've got an extra comment, but I've lost the context of your extra comment. So you'll need to give me a bit more information. All right, now we're getting a pretty clear consensus here. So I will stop that and I'll just share the result. And the clear consensus is that most people think we should be doing a choice style question here. And I agree. And that's what I'm going to do. Thanks, guys. All right, now we move on to a contentious issue, which is the roles of none of these and current alternatives. So here's the chocolate experiment question type from before, but there's a new column on the right. I would not buy any of these, the so-called none of these option. Most people who are new to choice-based conjoint instinctively think it's a good idea to add such an option, seeming to view it as a bit like having a don't know option in a normal questionnaire. However, there are real costs to having this in a study. The first thing is that some respondents are lazy and they get bored reading these complicated conjoint questions and they just choose I would not buy any of these as a way of indicating their displeasure, which means that your data gets bad. A second problem you've got, and this is a quite serious problem, is that let's say that half of your respondents just chose I would not buy any of these. You've ended up with a sample size that is half. And so you need to double the amount of people you pay to complete your survey in order to collect that information or to collect the same level of significance from your information. So it's a pretty serious problem. A third one is realism. In many categories, yes, people do have the option of choosing to not buy, but usually when you go to the supermarket, you do end up buying one of the things in the category that you propose to buy. It's quite unlikely that you're going to choose to not buy in the category, not impossible. But the problem we see in the data is the people's tendency to choose I would not buy when shown such an option in a questionnaire is much more common than it seems to be the case that they will choose not to buy in a supermarket or some other retail environment. So I virtually never, ever ask this style of question, but lots of people do. Similar to a none of these option is a I would buy my current brand option. This is a terrible thing to collect. I just can't say strongly enough you shouldn't do this. And I'll talk a bit about a situation when you can, but still I never would do it. It's got all the problems of none. But its real issue is interpretation of the results is really problematic. So let's say the current option they're buying is Dove dark chocolate sugar-free made in Belgium for 98 cents. And so they're like, well, I'm not going to switch for an extra cent. You've got no way of knowing that, so you can't interpret the data at all. One approach that people have come up with to try and solve that issue is they work out they ask people what their current purchase was, but there's an awful lot of noise in that. And so rather than when they're estimating the model using it as just another alternative, they instead fill in all the attributes for that current alternative and try and model it then, but that brings lots of other technical problems in because it kind of violates some ugly little technical assumptions. So, yep, just a terrible approach, don't do it. This one is a little more debatable. Now, the none of these problem I talked about before was pretty simple, right? Which was that if we do this none of these, we just get much less data potentially. And a very clever solution to this is you ask it as a two-stage question. You first ask them what option they'd prefer, and then you say, would you actually buy it? Now, when you do this, it does solve the sample size issue, so that's smart, but it makes it a longer questionnaire, so that's problematic. And it's a slightly confusing questionnaire, so that's problematic. The thing to keep in mind, though, is that if the reason you're wanting to do this is because you want to understand the category expansion effects, that is, you want to do this because you want to work out or you want to try and model the extent to which the attributes cause people to come and leave, to enter or leave the category, that's a worthy goal, but there's just no chance your model will produce accurate forecasts of that. They just never do. Category expansion effects, when put into choice models, are always really put in by using some form of secondary data or analysis of real world data. You can't get it from a survey. It's just too hard for a person to imagine whether they really would buy in a category or not, because there's too many other factors, you know. Would I buy the chocolate? Well, it depends if I've got someone coming over that night. I've gone too far. Let us ask another little question. And while we do that, Eric asks, does none of these help with estimating the size of the market? No, I don't think it does, Eric, because in the studies that I've looked at, and I've looked at this in a fair number of studies, I tend to find that, you know, it's certainly the case that if in your model all of the products' prices raise, you do get an increase in the number of people who say they'll buy none of them, but I've seen no sign that that increase is related to the actual price elasticity of the category as a whole. So I just haven't seen that ever work, but maybe I've been unlucky. And Marion says, how about having an option where they make a choice, but then a question asking whether or not they'd make that choice in the real world? That's excellent. And that is exactly the dual response. So you obviously typed that in before I showed that. All right. How are we going? Half of you have voted, and I'll close the poll at that point and we'll share the result. Right, and so everybody wants to have none, which is my option, but I will concede, not everybody, the majority, I've definitely misrepresented that have, but I will concede that that was perhaps a pretty biased question because you wouldn't have been in any doubt as to what I was recommending, would you? The next question we've got is, what should our sample size be? Now, let's just go back and look at our experimental design from before. We've actually still got a warning on it. And it's because our sample size is 300. We actually need to get rid of the warnings. I could play this like a computer game and I could keep, putting in numbers and seeing if I get rid of the warning. There's certainly an approach to doing this type of experiments, and it's an approach described in lots of textbooks. Lots is an exaggeration. There aren't that many textbooks on this topic. So 500 doesn't do it. What about 1,000? And I could obviously optimize, 664 or whatever the number is. Oh, that's 100, 1,000. So that's one approach. All right, let's see if 1,000 respondents is going to get us there. All right, I got rid of my warning with a sample size of 1,000. So that's a way, and Displayr will give you the guidelines for how to do that. However, I've never done that in the real world. When we're trying to come up with a sample size, first thing I just want to remind you of is there are trade-offs we can make. So the type of experimental design that we do, number of levels, whether it's partial profile, prohibitions, and some other things, dictates how large our sample size needs to be. So keep that in mind. But even with that kept in mind, these are the main rules for determining sample size. Some books maintain that you should aim for a standard error of less than 0.05, and we saw that how the software was giving us guidance on that point. Personally, I don't agree with this. 0.05 is just a made-up number. And the fact that often statistical numbers end up at 0.05, there's no law of nature that's just completely made up. And I've got this, and I've got the poll still showing, sorry about that. So we just missed one screen, which was this one here, which was showing us the difference, the trade-off between the various factors and how they determine the sample size, what it should be. And then we got to this slide here where I'm just talking you through the approaches to sample size. So as I said, you can do the standard error approach. I've never done it. Most of my career, I've just looked at credibility. So just like any other survey, you can come up with complicated formula for even a political poll for anything for the sample size. But you know, I've always gone with 300's what you kind of need as a general rule. If it's a big study, maybe that number becomes 1,000. I think any more science than that's a bit pseudoscience, but others disagree. Sawtooth have, if you like super precision, Sawtooth have a wonderful formula. So you just plug in these three numbers, number of levels in the attribute with the most levels, number of questions, and number of alternatives, and you get an answer, 556. So let's say you can reduce the number of levels in your attribute from 10 to 5. Then we need a sample size of 278. If you get a sample size, or sorry, when you create an experimental design, Displayr and Q also use this rule, and they'll warn you if you've got this, if you're below this Sawtooth criteria. If I needed to be really confident about sample size and I wasn't happy to go with my 300 is a good number rule, which served me well, there is a more complicated and rigorous approach, which is to use simulated data. And we've got a little blog post on how to do that, which we'll send you as a link. Roger, okay, Roger says, isn't 0.05 standard error more or less equivalent to a plus or minus 10% relative error on parameters for an attribute, so sensible in some respect? No, I don't think it is. So the standard errors aren't relative, they're absolute standard errors. So in a technical sense, the answer is no. The problem is though, consider going back to the utilities, right, Roger? Let's say that we've got an attribute with two levels. We'll call it, just brand. Qantas might be 0, Virgin Blue might be the second level, and we estimate, sorry, the utility of Qantas is 0, and the utility of Virgin Blue is say -10. Virgin Blue is an airline, for those of you who are not familiar with it. Now, we're happy to have a standard error of say 5 in that situation potentially, but if the estimated utility of Virgin Blue was say 0.02, then we'd want a standard error of 0.01. And so the problem with all of these kind of standard error type calculations is you need to know what you're trying to compare to what, and you need to have your final results before they're that useful. And then you need to come up with relative standard errors of what you're kind of doing, but none of that's factored into any of these kind of rules. Anyway, technical topic. And Roger says, exponentiate for impact on share. And that sounds too clever for me, Roger, so you're gonna have to break that down into simpler words, but it does sound cool. Jenna says, just to clarify, the more questions you ask for each respondent, the higher the sample size needed. No, the other way around. The more questions you ask for each respondent, the smaller the sample size needed. Now, there's obvious, and the reason for this is that, let's say you only ask one question, you actually can't learn that much from that one question, and so you need to pull information from respondents to learn anything. But there's a trick here. Obviously, it's not true that you can have one respondent and ask them a huge number of questions. And so there's a bit of an ugly little problem lurking in all of this. As I said, I tend to, when I did these for a living, I tended to use the same rules of thumb for determining sample size for conjoint that I used for any other type of survey. And Roger hasn't come back to explain on the exponentiate, so let us keep going. We then got to collect the data. I'm not going to read this. I'll just send you the link to this later. There's just some little tips on stuff to do here. It's all kind of related to how you program it all. There's a shortcut to importing the data directly into Qualtrics from Displayr and Q, and we'll share some information on that as well. And Jenna says, the number of attributes doesn't impact sample size as per the Sawtooth heuristic. Let's go and have a look at the Sawtooth heuristic. Yeah, no, it's not in their heuristic. You're right. But it nevertheless is true. So the point in me sharing all of these is that they're all different. They're all contradictory into different sense. They're just made up rules that people have come up with to resolve uncertainty. The math of why the number of, well, being very formal about this. When you increase the number of attributes, you reduce your number of degrees of freedom, and your number of degrees of freedom then can be increased by increasing the sample size. That's kind of a very mathematical way of describing, but it is certainly the case that the more attributes you've got, the more sample size you need. Oh, got it. And Roger was saying, so the 0.05 is, he's saying if you're looking at the relative error on share estimates, yeah, no, that makes sense. Yeah, but I still don't know how you'd go about. It's not what designs are. It's not what the designs are doing. That would be nice if we had relative estimates on share, but they don't. Oh, not in our software or any others that I've seen, I should say. But it's a great idea for the future. Alrighty. Gosh, I've talked for way too long. Sorry, everybody. If you've got any questions, I'll hang around for a few minutes, but we'll send you through the recording for all of our customers out there. Thank you so much. Bye now. Actually, I'm not saying bye now. You can still send questions in. I'll hang around for a couple of minutes. Well, the questions aren't flooding in, but people are flooding off the call. So this answering questions as we go seems to have worked, and I will close now, but send me an email if you have any further follow-up questions. Bye now.